Thank you so much for attending my thesis. This is a big moment for me, and it means a lot for you to be here. So today my thesis is called, the title is Examining Visual Expertise in Electrocardiogram Interpretation. This is mainly an eye tracking study and supervised by Dr. Dena and Dr. Mohamed Elshazly, who is in the Cleveland Clinic now. So I'll start with the background of my thesis. Basically, I'll try to anchor the background globally and locally. So for the globally, there are three main problems that I found in ECG interpretation, and the first one is the lack of ECG interpreters. A US-based study shows that 58% of potential life-threatening ECGs are missed due to non-competency of clinical interpreters. And 60% of those people who missed the interpretation, they claim that they performed the right interpretation, which is a little bit dangerous, especially when lives of people are involved. The second problem is that, as I said, the ECG is a very cheap and efficient diagnostic tool. So there are more than 300 million ECGs globally done yearly. And unfortunately, over 100,000 deaths are reported in the United States due to avoidable cardiac deaths. And maybe those avoidable cardiac deaths might be due to an improper ECG interpretation. This is the data in Qatar. And Dr. Al-Hijji was kind enough to provide us for the ECGs done in the year 2021. And as you can see, probably the ECGs were higher in the corona peaks. And there is a total of 28,000 ECGs done in the heart hospital alone. So this is like a big number compared to a small country. So for the challenges, again, this is the background anchored to Qatar, and as you can see, the data on 2009 shows that the main causes of deaths are like road injuries, and still it was cardiac heart problems, and then it raised to number 1, and even like number 4 and other diseases are the main causes of death in 2019. Again to what interests us as lay people. Soon we will be in need to understand our own heart rhythm, as the accessibility to ECGs is more and more available, like due to wearable devices. As you can see, the trends are knowing an increase in smartwatch acquisition by the year 2022, which is this year, and the wristbands and so on and so forth, which means that we will be in need to understand our own heart rhythm. So this is the outline of my talk. I'll be mainly dividing this talk into two parts. The first part is like just an introduction to the electrocardiogram, and the second part is my eye tracking study that I conducted. So just to be on the same page, I'll go briefly through some definitions. So what is the cardiac waveform? Basically, the cardiac waveform is just a description of the electrical signal in the human heart. And as you can see in the GIF, this is the electrical signal, and the waveform, it usually looks like something like this, with some waves like the P and the QRS waves. This is the waveform of a healthy heart, but it can be altered due to different heart problems. The second definition is the use of eye tracking. Eye tracking is just a technological tool that enables us to track where the person's eyes are looking at compared to a screen. And it uses the infrared technology, since the macula of the eye doesn't allow infrared to come. So the distance, the time it takes from the infrared to to be emitted from the sensor back to the screen. This time is used to know where the person's eye was looking. The third definition is visual expertise, especially in medicine. This is like a very big field by itself, and it is mainly anchored in a little bit in psychology, where the field tries to understand how a doctor or an expert who sees a medical image, what is the process going on in his mind before making like a verbalization of the diagnosis that they see. And this is an example of an MRI image. So it goes through different phases, like the vision, once you see the image, the brain activity, what the doctor thinks about, the observations made, and then finally the verbalization. And this is a flowchart that details this visual expertise process. And as you can see, that's the main part of the visual expertise is working memory. It's not what you see, and it's not what you verbalize, it's what you think. And like, as you can see, like there is a small portion of perception and a big portion of high-level processes, mainly the mental models. And these mental models is what I was trying to capture throughout my thesis, basically. I was trying to understand what is the mental model that people use in ECG interpretation. So these are the research questions. I asked 3 main research questions. Basically, like, to what extent expertise changes the accuracy of an ECG interpretation outcome. The second research question is that, is there a quantifiable difference among people who interpret the ECG correctly and people who fail to interpret it? And finally, depending on this collected eye tracking data, which is the metrics that I will use to quantify this expertise, basically, depending on this data, what is the most level of specificity to present an ECG for an interpreter in order to facilitate this interpretation process. So these are the 3 hypotheses that I started with, like one for each research question, basically. Basically, the first one, we hypothesized that the accuracy of interpretation depends on the category of the participant or the expertise of the participant, and I will describe like these categories in the study design. The second hypothesis is basically that there is a significant difference in the eye tracking behavior or the eye movement behavior of people who are experts and people who are non-experts, basically. And this is mainly quantified using the fixations or the fixation variable, mainly the fixation count. The third hypothesis is that there is a significant difference in terms of the eye movements. Not only the fixation where the people are fixating, but how they move around the ECG. And this is depicted by the fixations revisitation as a variable. This slide is a little bit trying to put this study into context. Mainly, I am aware that there is computerized ECG interpretation, and it is available, and it is going towards the right direction. But how can you balance between this computer interpretation and the human interpretation? Where can you find that balance? Especially that we are dealing with people's hearts. It's not something. It's a decision that needs to be made by the human. So how can we harness the best of both worlds? And this is just to understand the context of automated ECG interpretation. And I tried to find studies across the years, like starting from 2005 to 2019. And as you can see, that progress is being made, like starting from 11.3% accuracy in 2012, and moving. And here, like it's even worse. 70% are missed, meaning that it's just 15% accuracy, and moving on until like you reach 2019, where 78% accuracy is being reached. And the sample size is also growing. Like you can see, like it's 52,000 sample size, like compared to 500. So now I'll describe the related works that is directly related to the study that I conducted, and I didn't find many studies. In total, there are 4 across 3 different labs, and mainly two of them are from the lab of Dr. Caroline, who is with us here. I will start with the study that ignited this whole PhD thesis, which is the Kai paper of Dr. Ala. Basically, the idea behind this paper was, so if you have an ECG and you want to allow lay people to understand it, how can you facilitate this understanding? And Dr. Ala came with the idea of coloring the ECG like it was used in temperature maps, and it was already used in MRIs. Basically, you add color to the ECG. So this is like, for example, a normal ECG added, and if you add on its color, you can see that the waveform is a little bit elongated for the long QT syndrome, and then you can understand that the red color means that this is a little bit dangerous. You should like consult your doctor. This is like a simplified way to make the ECG understandable, but it's very, very powerful for a lay person, especially that the risks are high. Also, Dr. Ala attempted to use polar coordinates on top of colors, and it gave basically the same results, where lay people were able to see the red areas, to pay attention to them more. The second study, which is I think one of the very early studies, which basically it doesn't do much. It's just it just uses eye tracking in order to teach people how to interpret an ECG. Basically, it's just a way of teaching. Instead of using the mouse, you use your eyes. And this is an example of a doctor who is using eye tracking in order to teach his students how he is looking at the ECG. So this is the eye movement of the person, and technically the person is supposed to speak, but the computer is on mute. So he is verbalizing his interpretation, and again we're coming back to this idea of human expertise, where there is this process of verbalization. And the study before the last is a study that used eye tracking, and it just quantified where people are looking at. It just did a pure quantification. It didn't analyze this quantification. It didn't use any statistical tests. It basically made us aware that people, for example, look at lead-2 the most, and it's just percentages, not even minutes or so on. The last study is a study similar to what I did, but the main goal of this study was just to categorize how people interpret the ECG into themes, and it was mainly based on interviews. It didn't quantify. It didn't use any statistical tests. It just attempted to interview people and then confirm these observations that people made through heat maps. Yeah. So these are the 4 studies that are directly related to my research, and now I'll move to the study that I conducted, and starting from the materials and methods. So these are the variables that I have in my study. I have one independent variable, which is the expertise level of participants, and I will describe the categories in the next slide. The dependent variables, which are the fixation counts, the fixation revisitation, and the accuracy of the final ECG interpretation as the end goal of the study. And then I also have one control variable, which is the time allowed for participants to look at the ECG, which was limited to 30 seconds. Yeah, for the study design, these are the categories that I'm talking about. I have 5 categories, which are the consultants, the fellows, the nurses, the technicians, and the medical students. The study was conducted through 2 different institutions, Weill Cornell and Hamad Medical Corporation's Heart Hospital. For the ECGs, we selected 10 different ECGs, of course, like under the supervision of a cardiologist. And these 10 different ECGs, they represent all like the major heart diseases or the most common heart problems. And these are the 10 ECGs that I used in the study. So as the people start their interpretation using eye tracking, as the people like start the interpretation, I asked them like some questions about how many credit hours did they learn, or how many credit hours did they have. Now they are interpreting the ECG, and then you can see that medical students are people that have the lowest number of credit hours, 1 to 5 credit hours. It's not just hours of learning, it's like credit hours throughout their medical years. And then moving on to nurses, technicians, and then fellows, and then consultants who even have like more than 30 credit hours. Again, for the questionnaire, like I asked people like how often do they interpret the ECG, and the majority of people, they interpret it daily, if not weekly or occasionally. I had some exceptions of people like who never interpret the ECGs, and those are like nurses who are not in the cardiac department. They rarely or like they occasionally have to deal with an ECG. Yeah, and you can see that the majority of people like they interpret the ECG daily. So for the assessment metrics, these metrics we selected them based on the hypotheses, the 3 hypotheses. These are mainly the accuracy of interpretation, the frequency of lead revisits, and the interpretation similarity. And it is important to mention that eye tracking is very rich, is a very rich tool, and we could have like chosen more and more metrics, but we decided to focus on like 3 main metrics in order to confirm or deny our hypothesis in the best way. In order to reach statistical significance, I had like to assess like these metrics fairly, and I did basically a disposition of areas of interest, and I had to select two dispositions, which are the long lead versus short leads. So the short leads are area number 1, and then the long leads are area number 2. And for people who are not familiar with the ECG, so basically the long leads are the same as short leads, like lead V1, it's the same here, but only it's like elongated across much more time. So this signal is the same in this area, and like you have more signal in order to observe how the heart is behaving. And then of course, like I had the grid-based disposition where I divided the ECG into 24 equal areas, plus the information lead that I couldn't basically I couldn't allow it to be on an equal area as the other 24. For the results, these are the results. So I start with the results of medical students because these are the category that I had like many participants, and at the same time they were the category that participated first in the study. And you can see as the ECGs are getting more complex, the accuracy of interpretation is getting lower and lower, and you can see that the worst accuracy is 31% for the left bundle branch block, which is a fairly complex ECG to interpret. These are the variables for medical students, and you can see like fixation count, fixation duration, and the time to the first fixation. And what is important to observe is that medical students, they almost always fixate on lead 2, no matter what the ECG is. They always like look at lead 2, and even they look at lead 2 the most, and at the same time, lead 2 is the first lead that they observe. Since it is shown here like the time to the first fixation, it comes as second, and mainly AVL. It's because it's in the center of the image. when the image is projected onto computer, you are most likely looking at the center. But then as soon as you diverge your gaze, you look at lead 2, which is in the bottom area of the ECG. This is the accuracy results for all the categories across all the 10 ECGs. And you can see that the accuracy is a little bit variable, but what is important to note is that consultants, they have like almost 100% accuracy across all the ECGs, which is expectable a little bit. But what is a little bit unexpected is that there is always this variation, especially like for complex ECGs across even the more experienced practitioners. And this leads us to confirm our first hypothesis, which is that there is a significant difference among these categories in terms of their accuracy of interpretation. And we reached a p-value of 0.023 using the chi-square test. And why the chi-square? Because the data is dichotomous. This is the density distribution for the fixation duration across all the 10 ECGs. And what we can observe is that the data is left skewed. The reason why it is left skewed is mainly because you can see, for example, like in the atrial flutter ECG, you have in the atrial flutter ECG you have two peaks. The same is in the atrial fibrillation ECG. You have two peaks, and you can see this trend across many other ECGs. And this is mainly because there are some areas that have zero millisecond, and the reason why you have 0 is because simply people did not look at this area at all. Some leads, they don't look at them, and especially like the information lead at the bottom, which is like the one that is very short. People don't look at it at all, which gives me like a lot of 0 data, which accumulates over the 0%. And then of course, like you have some exceptions where the people spend a lot of time looking at that lead, like they get stuck on that lead, which are the in the the most right corner. And this is the second variable, which is like the fixation count, which is to confirm the second hypothesis. And as you can see, the fixation count varies a lot across different categories, and sometimes it is divided into half. Like for example, like you can see that medical students, they have almost double the count of fixations compared to the consultants, which is these two numbers. And also this is like for the whole ECG, and this is across each area, like in the grid-based distribution, each lead. And you can see that it varies between 9.93 to 6.57. And the reason why I chose the median, just because the data is left skewed. Like you can't use the mean unless the data is in a normal distribution. And also, like I conducted a statistical test for this finding, and using the Kruskal-Wallis test, I reached a p-value of 0.325, which is significant. The third variable, which is the lead revisitations, and this lead revisitations refers to the third hypothesis, where I'm trying to understand how people are navigating through the ECG, not only where they are fixating, how they are navigating, and I found out that it's the same thing. And the reason why I used the mean here is because like the revisitations are fairly normally distributed, and you can see that consultants they revisit leads less. They just focus on one lead, and they go to another lead, and they almost never come back. Which means that they know where they are looking at. They are not confused. They just focus and then move on. And you can also see it in the standard deviation, where for example, like technicians, there's almost like zero standard deviation, which means that it reduces the mean basically. And I also conducted a statistical test using the one-way ANOVA, since the data is normally distributed, and I reached an F value of 30.56, which is larger than the critical F value, which is like 2.36. And I tried to basically replicate these results on top of a heat map, and you can see throughout the heat maps that the behavior of participants changes a lot. So this is for the same ECG, the heat map, like the left bundle branch block ECG, and you can see that that people like focus on the long leads, like lead 2 that I mentioned here, lead 2, and like mostly like the rhythm strip, compared like to consultants who look at a totally different area in the ECG, like the upward area, which is like for the short leads. And you can see that that trend is a little bit replicated for people of higher expertise. People of higher expertise, they have almost like the same behavior because they know where they're looking at, compared like to, for example, like medical students or nurses. And also like an important observation that I made is that for example, like technicians or nurses, they go through the whole ECG, and this is mainly that I found out through the interviews that I conducted with them. Mainly nurses, they are asked to look at the whole ECG and to just identify signs of heart abnormalities. They are not asked to diagnose what is the diagnosis. They just need to verify everything, nurses and technicians. While, for example, consultants, they have a different purpose in mind. They are trying to identify what is the problem in the heart. Yeah. And these are two Sankey diagrams. Their goal, I was attempting to understand, like this is like these Sankey diagrams are for the revisation or the movement from one lead to another. Where do they start and where do they end up with? And these are for two ECGs, the same ECGs that I mentioned, and these are for consultants mainly. And as you can see, the behavior changes depending on each ECG. In some ECGs, you'll need to go through different leads in the ECG, while for others you no longer need to look at the topward area. So to summarize, I confirmed the three hypotheses. The first one, which is the accuracy of interpretation. The second one for the fixations, and then the third one for the revisitations, basically. Also, I conducted a questionnaire, and this is I used the same questionnaire of Alan Davis that he used in his thesis, which is very much related to what I was doing, simply because the questionnaire reflects the goals that I was aiming to reach in my thesis. And basically, the first question is, it refers back to this visual expertise that I mentioned in the beginning. I was trying to understand whether people are aware that they have a visual expertise or a system that they use in order to interpret the ECG. And I realized that most people who are not experienced, especially the medical students and nurses, they are not aware of this visual expertise or this interpretation system. They just think that you just look at an ECG and you identify the problem. While, for example, the people who are aware, the fellows and consultants, they might say yes, they are aware that their interpretation system has changed over time. And it is important to mention that visual expertise, it changes across time and across expertise. You gain some skills and you lose some bad behaviors that you do across time. And the second question echoes a little bit like the first one, where I prompted people, how did they change this? How did they acquire their ECG interpretation skills? And I gave them three choices. She's I learned it through school, medical school, I learned the system from other colleagues, and then I developed the system myself, or a combination of all. And as you can see, like the majority of people, like they say they just learned it through school, while the consultants or the expert people, they are aware that they acquire some new skills through colleagues, through like a combination of the three, and even like some medical consultants, they say that they developed the system themselves based on the patients that they see. This question, basically, it was just to understand whether people are aware, whether they are aware of where they are looking at the most, and this was confirmed through eye tracking. And people said that, like medical students especially, they said that they focus mostly on lead 2 and the rhythm strip. I should mention that in the questionnaire I did a mistake where I didn't allow people like to mention like different leads. And consultants, they always told me that it's not always lead 2, it's not always only one lead, it's a combination of them all. For this question, which is like the recording and amplitude settings, which is a little bit surprising, is that like the majority of people, like they never pay attention to the recording settings, and this is mainly because of either like ignorance in terms of like medical students or in terms of expertise. Consultants, they don't need to look at the settings because they have learned them by heart through experience. These are. I also conducted interviews with people after they conducted the ECG study, and basically I did not have. I had a set of questions in mind, but I also let people give me their feedback, basically, and I summarized the whole interview the whole interviews into a digest of 3 main points. Basically, I wanted to understand how people perceive their own ECG interpretation, and people always told me that the ECG is not the whole story; it's just part of it, or at least either the beginning of it or the end of it. Like I said in point number 1, it might be the beginning of it, like to identify what is the problem in the heart, or the end of it to confirm whether what the doctors had in mind is correct or not. The second point was a little bit interesting, where people they said that they change their interpretation behavior when they are in a group. They concede or they object usually, and usually the dynamics is that most people, like they don't want like to give their final say. They usually like try to consult among each other, especially like the consultants, and I saw it firsthand where like a set of consultants, they gather around an ECG and they discuss it. Finally, the third point, I asked people like if you wanted, since the results, I didn't share with them the results, but since the studies say that the results are not too good in terms of ECG interpretation, how do you perceive an ECG interpretation training system? If I wanted to develop a training system, what would you think of? Like, how do you see like using eye tracking and stuff? And I got some feedback, which I will show in the next slides. But before showing the future work, I'll just conclude in basically one slide. And this is a little bit so intuitive. To conclude that the more expertise people have, the higher their accuracy of interpretation. But at the same time, they fixate less and they spend less time on the ECG. They also revisit leads less. For the limitation, I had 3 main limitation of my study. Tried the participants. 63 participants is not a lot. And also I had an unbalanced set of categories. I had more students than, for example, than consultants, because it's very hard to reach. But I made sure like to I made sure like to, when I was analyzing, I made sure like to balance these categories. The second limitation that I realized after I conducted the study, which is the ECG's non-uniformity. Some ECGs, and I can show the ECGs later on, some ECGs, they don't have the same disposition. I had, I think, 7 ECGs that were the same, that had the same disposition, but 2 or 3 ECGs, they were not uniform. And it's made me like change a little bit my analysis, but it didn't affect it much. And finally, like the assessment. I tried as much as possible like to be fair in terms of assessing people's expertise. I gave people, for example, like 30 seconds for all the categories of participants, but and this is of course like discussed with Dr. Elshazly, who is a consultant and who is a teacher of ECG interpretation, and he said that 30 seconds is at least enough for students to realize what is the problem in the ECG. It's not enough like to make a confirmation, but it's at least enough to find cues. Yeah, so this is like the main limitation. So for the future works, this is basically incorporating people's feedback through interviews in order to design a training system where I'm planning like to use artificial intelligence in order to predict from the visual behavior of people, like whether the person looking at this ECG is an expert or not, because already through heat maps I could see and identify some trends. And also this will allow me to collect more ECGs and use them in the training, and that way I will be able like to have an adaptive ECG data set. So I started this future work by doing a literature review to understand what is possible like using machine learning and artificial intelligence to design a training system. And basically I found out that these are the main themes that occur. Basically, either you detect events, like for example you detect heart abnormalities, which is not my field. You classify, which is important, like I can, for example, classify based on the visual behavior how much people are expert. I can do information retrieval, which is mainly my whole thesis. It was about mainly information retrieval and understanding. Prioritizing data, mainly prioritize which areas of the ECG to show to people and which areas to not show. And finally, to predict people's answers, people's diagnoses, and so on and so forth. This is my published work, and mainly two journal papers that describe this whole thesis, and other theoretical journals that describe mainly the theoretical process of visual expertise and the medical trends. And finally, I would like to acknowledge the people who contributed very much into this thesis, mainly Dr. Dena, my supervisor, Dr. Elshazly, my co-supervisor, and Dr. Al-Hijji, who is from the Heart Hospital, who was very helpful in order to, that facilitated data collection, the access to consultants who don't have time, and finally Dr. Ala, who joined the adventure by the end of my ECG, and who provided like valuable feedback. And also, like, I would like to thank my cousin who helped me understand the ECG, as he's with us today, and he's like a medical resident. And thank you so much for you all for attending my dissertation. I would love to hear your feedback.